Hey everybody, just getting myself set up here. Feel free to use the chat if you have any questions, but let me pull up our slides. Hey Eric, so I'm gonna go ahead and I stuck in the slides link so that you all have access to that into the chat. And let me go ahead and start to share my screen to our slides. All right, so today we're gonna be, let me go ahead and start my video. Okay, today we're going to be applying the integral. It's April 14th. We do have an assignment today and that I'm hoping to dig into. Before we begin, just some few overview is that the session will be recorded. Be mindful of that. I'll be uploading the recording of this by 5 p.m. today. Our class norms: active listening, one mic, be kind, respect different ideas, and participate. So make sure that you, for your credit today, you are participating in the chat, or if you want to audibly participate, you can raise your hand and audibly participate and be present. So I'm hoping that you're trying to be present into this to the best of your ability, as in taking notes, things like that. Online norms: use the chat to share ideas or ask questions. You could provide feedback by using the little reaction button. You could raise your hand to speak, again, if you want to do that audibly. Turn off your mic if it's on, and then refrain from multitasking. Again, do this to the best of your ability. All right, let's jump into our agenda. Let me just make sure that okay, great. We have good. No questions in the chat. All right. So we're going to jump into the agenda. We have a quick check-in question. I'm going to go over a bit of some updates for our class, and then we're going to be looking at the assignment that's due today at 11:59 p.m. All right, here's our check-in question, everybody. What show are you watching on Netflix? Or it could be what movie or what show are you just currently watching? Go ahead and type that into the chat. But I keep seeing Money Heist. Yeah, that's a popular one. Grey's Anatomy. I didn't know that was on there. Okay. Eli or Ili, I don't know. But I've been seeing that mentioned a lot. Legacies, Cable Girls. Okay, YouTube. YouTube has some good stuff. Awesome. Let me have a little bit more. Imposters. Yeah, I think I'm watching like 3 shows or something like that on Netflix right now. All right, everybody. So some quick updates. Our AP live classes is going to be every Tuesday at 12:30 noon. And the next update is that every week now, we're going to have 3 lessons or assignment per week. And that's including the live lessons that I'm doing right now. So for example, in this week, right, we're on Tuesday. We had yesterday's reviewing integral rules. And we're right now having a live lesson. We're going to be applying integrals in the live lesson. And then tomorrow, we're going to have our last lesson for the week. Notice how Thursday and Friday, we don't have any math assignments. So 3 lessons per week. I am still playing around what days work best, right? But I am initially liking Monday, Tuesday, Wednesday. Again, feel free to provide any feedback on that in the chat, or you could send me a text and remind on what types of days would be better. But I kind of like it early in the week. Next updates, AP exam stuff. So some of you have been getting emails about AP exam information. If you don't know it yet, the AP exam is going to be Tuesday, May 12th at 11 a.m. now. It used to be that it was 8 a.m. or something at the school, things like that, and it's going to be online. They're going to give us more information. Sorry, guys. I had to save something. Let me go back. Okay, sorry. They're going to be giving us more information as the date is approaching about how the online stuff is going to work, because I also have a lot of questions about it, like how's it going to work. They're also saying that they'll allow you guys to take pictures of your work and upload it. So I have a lot of questions about it. I also have questions about calculators, like are we going to be able to have you guys use Desmos instead? There's a lot of good questions I have. So here, if you read, it says for the first time ever, AP tests are going to be done as open note tests that can be completed at home on an accessible device, either your Chromebook, tablet, or even a smartphone. You'll have the option to type and upload your response or handwrite it and then take a photo. So those are some important updates. So it says this: most exams will have 1 or 2 free response questions. That means that's the type of question that's not multiple choice. That's the one that you're either writing out and showing some math work. And it's going to be timed separately. You'll need to write and submit your responses within a certain allotted time for each question. For most subjects, the exams is going to be about 45 minutes long, plus an additional 5 minutes for uploading. You'll need to access the online testing systems 30 minutes early just to get set up and make sure that you know how to use everything on there. So that's just some important updates on the AP exam. Again, feel free to use the chat if you have any questions about that. Okay. All right, so today's task, we're going to be submitting the assignment on Google Classroom, and the task looks like this. I titled it as virtual task number 2. We're going to be applying the integral now into context. That means a real world scenario. And then what I included is screenshots of rules and important ideas that you should know in order to do the task. One of them mainly being that what is the integral? It's an operation that takes the antiderivative. We also call it the accumulation function because it accumulates a quantity. Basically, that area under the curve that it accumulates is going to be a quantity. And usually it's a specific quantity under a rate graph. And then the basic rule is if you take the integral of x to the n, the rule is 1 over n plus 1, x to the n plus 1. That's basically the antiderivative. Again, why is it useful? Finding the area under the curve helps us determine quantities under rate graphs. Like if you have a profit function, then the quantity, like a profit rate function, and then the quantity under the graph will represent, for example, the amount of dollars or something. So what we're going to do next, we're going to first take a look at the resources we have, which I kind of just did with you right now. I was reading through like what was the important information we should know. Then we're going to start the task together. Now, if you have the slides, you could go ahead and click this link, and we're going to be starting the task together. Maybe answer some clarifying questions you might have. And then whatever we don't finish together by 1, right, you're going to submit the task and finish it on your own with all your work shown onto Google Classroom today. Does anyone have any questions on our directions first off before we get started? All right, cool. So, yeah, by the way, to participate today, feel free to audibly participate by raising your hand or type in the chat box. That is perfectly fine. All right, let's go to the actual task. I'm hoping that you guys have the task open, by the way. Let me also just link it in case. There we go. Actually, let's all just open it together. I'm going to open it together with y'all. Okay, it's not working. 1 second. It has to be right here. Just going to go back to our, let me go ahead and share it into the chat so that we're all in this task together, and we're all just reading what exactly is on this task. Again, I'm going to just try to type it out using the Google equations. Great. 1, 2, 3, 4, 5. 5 of you are on there. I'm going to put the link in the chat though if you need help getting there. All right, let's all get in there. All right, great. So again, the first step is to look through the resources. I already read through the first part, right? The important power rule for integrals. We have that rule and we know a little bit about why it's important. This was a problem we kind of did before we got jumped into this like quarantine, but we were kind of modeling what does the area under a curve represent with different types of function. For example, this situation below, it was we had this integral from 0 to 75 of P of C dc. P represented the rate that a coffee shop makes profit in dollars per ounces. So then that's why right here, the rate dollars per ounces is basically the height of my rectangle. I want to sketch a rectangle if I want to figure out what area is. So then my height was dollars per ounces. Per means division. So that's where that comes from. And then my x-axis, it says of coffee sold C. My x-axis is just ounces. And then when you multiply the base times height to figure out what does the area under the curve represent, ounces canceled. And for this particular problem, the area under the curve would have represented the total money you made, the total dollars. And again, here, take a look at the notices to figure out what the units of the area under the curve represents. You can draw a rectangle like we did here, multiply what the base is, x-axis, with what the height is, the y-axis. Let me know if anyone has any questions about this kind of review conceptual idea and problem. And please just type it out into the chat so we could discuss it further if you have questions. Okay, looks like we're set. Let's dig into the problem then. So here we go. Problem 1. Someone's calling me. Not answer. Okay, problem 1. Water is pumped into an underground tank, okay, at a constant rate of 8 gallons per minute between t equals 0 and 3 minutes. Okay, that's the problem. Let's read it. Let's try to figure out what this means. Water is pumped into an underground tank. So water is going into a tank. It's going at a constant rate of 8 gallons per minute. Look at this, guys. This is a rate. Gallons per minute. Anytime you see that per right there, that's gallons per minute. That's a rate. And it's doing this for 3 minutes, 0 to 3 minutes. What I'd like you to do right now together in the chat, what do you think 8 times 3 represents when you're thinking about the context of this problem? That means what scenario that's happening here. In the chat, go ahead and participate. What does 8 times 3 represent in the context of this problem? So Eric says the flow rate. Total amount of water in the tank after 3 minutes is what Alexa says. Okay, awesome. So we have flow rate, we have total amount of water, we have an IDK. That's okay. Let's just get some ideas out there and we could figure it out. Elizabeth agrees with Alexa. Anyone else want to go ahead and jump in with what you think 8 times 3 represents in the context. So we have 2 people who think it represents the total amount of water in the tank. Kelvin agrees with Alexa. Okay, 3 people are thinking that's what it represents. All right, let's go ahead and figure it out then. What does 8 times 3 represent? It says from iPhone. So who is iPhone? But let me know who you are. It says from iPhone to everyone. It represents the rate of the gallons per 3 minutes. So we have 2 people who thinks it represents rate, and we have like 3 or 4 people who says it represents the total amount of water. Let's figure it out. So 8 comes from here, right? 8 times 3, so 8. So we have 8 gallons per minute. So what I'm going to do is I'm going to put 8. I do not know why it's bolded. I don't like that. 8. And it said gallons per minute, so I'm going to do this. 8 gallons per means it's division, so it's going to be gal per min. Step 1. That's how I figure out what the units are. Oh, Huda. Hey, Huda. Okay, that's 8. Okay, now we have times. I'm just going to copy this. Times. And what was 3, y'all? Tell me what 3 is. 3 what? Minutes. Thank you. All right, now if I reference what happened above, right, with the profit, right? If we're imagining we're kind of like a rectangle, we have gallons per min, and then we have min, height times the height times the width. Basically, something should cancel out. In this case, we got dollars. What cancels out in this problem right here, y'all? Minutes. Y'all agree that these minutes right here will cancel? Yes, that's correct, guys. This minute cancels with this minute right here. So what are we left over with? 8 what? Oh, I'm sorry, not 8. 8 times 3 is 24. Sorry. 24. 24 what? And Eric says gallons. That's correct, y'all. So 8 times 3, if you write out the units, see how it's important for me to write out these units right here? That's how you figure out what the area under the curve will give you. I was trying to color this. It's not working. It was important to write out these units right here. That for me was key. That's basically, Alexa, it looks like you were correct that 8 times 3 represented the total gallons that was being pumped into that underground tank. Let me know if anyone has any questions on problem 1. We just did that together. That means you have problem 2 and problem 3, and then there is a overall problem 4 to submit. Now problem 4 is modeled just like the above, but everything put together. Okay, let's move on to problem 2. Okay, now we have a different scenario, or we have not a different scenario, but instead of water going in, it's being pumped into a tank, we have now that water leaks out of the tank. It's leaking out of the tank at a rate of T squared plus 1 gallons per minute for 0 to 3 minutes. Now the next question is saying, interpret what is this integral right here. What does this integral represent with the context of this problem? And let me remind you all before you start typing that the integral gives you the what under the curve. If you look back at what your resources are giving you. The area under the curve represents, yeah, Eric says total area. That's correct. The area under the curve represents total area. So let's go back down to the problem. So if I know that the integral, this symbol right here, represents total area, what in the world is the total area under this function is basically the question, right? Like, well, what is t squared plus 1? What does t squared plus 1 represent in this problem? Look back into the units. See if anyone has any idea. So the integral does represent the area under the curve, and the area under the curve does have a special unit. Okay, looks like Betsy said the rate that the water goes out. Alexa says the gallons per minute. The leak rate for the water in 3 minutes / the total water loss. Okay, total water loss. The total amount of gallons per amount that's leaking. Okay, awesome. So let's go ahead and figure it out. So again, remember y'all, if we're trying to find the area of something, we usually do the height of the function times the base. The height is the function, gallons per minute. So let me just type this out first off. So first off, we're trying to figure out now, what does this represent? So that, and then, ooh, I don't like that capital T. And we knew it was T squared plus 1 gallons per minute. That means it's the same unit as this one here, gallon per minute. I'm just gonna copy it. Yeah, I'll just take that times 2. Y'all agree first off that my height of the function is gonna be T squared plus 1 gal per minute, because that's what's given to us in the problem. And then Huda, you said the total amount of gallons per amount that is leaking. Okay, let's go ahead and maybe that's correct. Let's see. And then how many minutes, y'all, was the water leaking out? For how many minutes? 3. Perfect. So I'm just going to kind of copy and paste this 3 min. Keep your units always with you. So notice how I set this up, and the reason why I'm setting this up is what I'm doing is I'm doing base times height. Height is the T squared plus 1, and keep my units. And then my base was from 0 to 3 minutes, so 3 minutes. Again, guys, so what is going to cancel out here? Mins. Yeah, so in this scenario, though, we can't really kind of multiply these two numbers, but what we know is that the area under the curve, let me write that down, is going to be minutes. Sorry, total, no, I'm sorry, cancels out is minutes. It's going to be what? What's the area under the curve going to be? Total gallons, thank you. Gallons that pumped in or leaked out, which one? Leaked out. Perfect. So first off, we have that the area under the curve is going to be total gallons of water, maybe water that leaked out. Okay, so we've interpreted what this now represents. And we could say the total gallons of water that leaked out, let's be more precise, in 3 minutes. Like exact, because it's saying from 0 to 3, or you could say between 0 and 3 minutes, however you want to be precise with that, represents into the context of this problem. So that's what this integral represents. Well, why don't we calculate that integral so we can figure out how much gallons of water did leak out? So we need to calculate what this represents. I can just bring this down. Hopefully you did the assignment yesterday reviewing integral rules, but we could go ahead and do this together. Step 1 is to take the antiderivative of t squared. What is the antiderivative of t squared? Not the derivative. So the derivative of t squared is 2t, but we want the antiderivative of t squared, y'all. What is the anti? Good, Alexa, 1/3 t to the 3rd power. That is the antiderivative. Remember, be careful, y'all, because y'all took the derivative. Okay, let's go ahead and put that in. So it's t to the 3rd on top, all over 3. Or it's the same thing as saying 1/3 t to the 3rd. Now, what is the antiderivative of 1, though? antiderivative. That means if I take the derivative, it's going to give me 1. X, X, perfect. Or in this scenario, it's the variable's t. You could put X if you want, that's totally fine, but that is my antiderivative, right? X to the third over 3 plus X, that's totally fine. And now what we're going to do is we're going to plug in the upper number minus plug in that smaller number. Remember our rules? I'm going to use brackets for that. So I'm going to plug in first 3 into this. And again, if you want to do this assignment with paper and then upload it, that's totally fine. So I just plugged in 3 into the first function. I'm going to close my bracket. So that's my first substitution. Minus, now I don't know, it's probably the font that I'm using that it looks kind of funny. I might change it to a different font. No. I don't like this font. Sorry, guys. I'm messing around right here. There we go. And then I'm going to plug in 0 now instead of the 3. So I'm going to go back to where the parentheses are, switch that to 0. Let me see if I could change this font because I don't like this. It's Railway. Okay. Arial maybe? Yeah, that looks better. Look at that. Okay, now we got to evaluate this. Now, first off, I hope if anyone has any questions on what I did right now. So remember, step 1, we took the antiderivative. Step 2, you have to plug in the top number into the antiderivative. Then you subtract and you plug in the lower limit of the into the antiderivative, which is this part. So just making sure we all got that, I hope. And then again, check for any errors if I have it. So then that's B minus A. Yeah, that's correct. Yes, usually always the top, plug in the top number, subtract, then the bottom number. Yeah, so B minus A. That's correct, Eric. Okay, then. Let me know if anyone has any more questions on that. So now the cool thing though is that this part right here, what does that become, everybody? 0 to the third divided by 3 plus 0. What is that? 0. Yay. So that just totally goes away. So all I got to calculate now to determine how much gallons of water is being leaked out is this part. And then it keeps going down here. Stop. Yeah. So now I just got to figure out what this part is. So 3 to the third. Oh, Eric, you got 12. Okay, 3 to the third. That's 3 times 3 times 3, 27. Am I right? Divided by 3. 9 plus 3. I think it's 12. Yeah, I think it's 12. Y'all agree on that? 12? Great. And then, guys, 12 what? 12 what? What were our units again? Gallons. That is leaking out. Or of water loss. I like that, Eric. So we have this problem where, first off, water is being pumped into a thing, whatever it was. It said it was underground tank, right? It was being pumped at this rate for this. So it was entering in, you had 24 gallons, right? And then you have that water was going, like you're losing 12 gallons of water though, between 0 and 3 seconds. Now we're gonna go ahead and put it all together in problem 3. Now here's the thing though, because our time is out. So that's gonna be your job today, is to go ahead and put this whole problem together now, putting it all together. You have a problem now where water is being pumped into a tank at a constant rate of 8 gallons per minute. That's what we just did in problem 1 above, if you scroll up. And at the same time, water is leaking out of at t squared plus 1 gallons per minute for 0 to 3 minutes. That was problem 2. But now it has this. At t equals 0, the tank contains 30 gallons of water. So initially at 0 seconds, whatever, it had 30 gallons of water. Now, your problem that you're going to do is you're going to put all this information together. How many gallons of water are in the tank at t equals 3 minutes? You can type or you can insert a picture of your work. And for this one, I do not want you to like feel, by the way. Was it seconds or minutes, y'all? It was minutes. I think it's actually important to kind of clarify that this was between 0 and 3 minutes. So I'm just making sure I go back there. Just always go back to the problem and add your units because it kind of can help you out when you're answering that last problem. So the last one is you're going to put it all together and you're going to try to figure out how many gallons of water is in the tank at 3 minutes, given that one, there's water going into the tank and it starts off with a certain amount of gallons of water, and the fact that the tank is actually leaking some gallons of water out. So it's leaking, it has like a leak in the gallon. And your goal is to find out, well, how many gallons of water is in the tank in problem 3. Does anyone have any clarifying questions for problem 3 before y'all get going? And then there's problem 4, by the way. So you guys have like two more problems there to complete the assignment. I am mostly interested in seeing how y'all are tackling this problem, not about correctness. We're going to be giving each other feedback on these problems, so don't be like stressed or something if you're uncertain about your work. All right, guys, let me go ahead and respect your time. I look forward to seeing what the pieces of ideas that you have when you submit. Yeah, do you make a copy of this? Yes, please make a copy of the assignment and then submit it onto Google Classroom. Make sure that you fill in all parts. Remember, we already did problem 1 and problem 2 together, so you just have 2 more problems to do, and it's putting all the ideas that we just talked about together. Lastly, before you guys get going, I hope you all enjoy. The link won't show up for me. Which link? The assignment link, Kiara? Okay, I could go ahead and link it right here into the chat. Oops. 1 second, let me open it up. Yeah, for some reason it wasn't. Let me just share the link with you. Okay, Eric just got you. He shared the link with you. Cool, so let me just make sure if you got that, Kiara. And then again, when you take a look at the assignment, I went ahead and this stuff is already typed in for you, but you can feel free to delete and type out what you want if you want, like, if you want to better phrase it. All right, y'all, last thing before y'all go. I know, you know, times are tough. Tomorrow, Wednesday, there's going to be the senior town hall meeting. Try to make it. It's going to be tomorrow at 11. That's when you guys get to talk about, like, you know, CSP or any questions you have about that, because we all know that there's like a petition and whatnot going on. But I'll tell you guys this. You must tell yourself, no matter how hard it is or how hard it gets, that I'm going to make it, whatever it is, right, that we're all going through. We're going to make it. Just some positive words for you there. Feel free to text me on Remind if you have any questions, or even to check your work before you submit. All right, everybody. Bye. Miss you guys. Thank you for your participation.